My name is Rudy Eccles, and I'm the Energy Services Manager for GreyStone Power Corporation.
What is the purpose of tonight's meeting?
Well, we've got 108,000 residential customers, and the majority of those people feel like that solar is a coming thing and it's important, and it's the opportunity to give them an opportunity to save energy. So if that's how they feel, then what we need to do is to educate them on the wise and efficient use of solar, to make sure when they start making their solar decisions that they're educated about it.
How many people do you expect for tonight's meeting?
We've got about 225 RSVPs. I'm honestly looking for approximately 200 people here tonight.
I'm David Webb, an engineer with GreyStone Power, and these solar panels generate clean, renewable energy without generating noise, pollution, or greenhouse gases.
I'm Wayne Glover, and we're excited about solar opportunities here at GreyStone Power Company. Our engineers and marketing teams are learning all that we can about solar energy. And we want our members to be knowledgeable as well, so that when it's affordable, we can add it to our generation mix. If you have any questions, issues, or concerns, please contact your GreyStone Energy consultants.
I'm Chet Toller. I live here in Douglasville, and I own a small business. I have had an interest in solar power, alternative energy sources for a long, long time, and I'm grateful to GreyStone for putting this seminar on. I really wanted to come to this tonight, and they were filled up, but they allowed me to come in. So anyway, I hope to gain knowledge of the solar power and the equipment, the people that are involved in installing it. I may very well be a customer for them, so that's why I'm here.
Good evening. My name is Rudy Eccles, and I am the Energy Services Manager for GreyStone Power. And on behalf of GreyStone Power, I really appreciate all of you coming out tonight. A lot of you could stay home and watch NCIS, but it's a rerun. I've already checked. And if anybody is going to the Braves game tonight and missed that, it's in New York. I don't believe what you're telling me. So it's good to see everybody out here tonight. Gosh, I know a lot of people out there, and how many of you have been to one of our energy efficiency seminars? Raise your hand. Yeah, good many of you. Well, it's good to have you here tonight. We really appreciate you being here. I want to thank Trish for cooking our cookies for us tonight. She baked them here, and she is also our photographer. So Trish, thank you very much. And I also want to thank all of the GreyStone team that's here tonight, that's worked hard to bring this seminar to you. And here's a heads up to everybody. Tonight we're gonna videotape the meeting, and we're gonna videotape it so we can put it on our website, and other people that couldn't be here will be able to see it. We actually had 225 RSVPs to come here tonight, and I don't know how many we got here right now, but you know, we're not at capacity, so we're going to have some people probably coming in a little later, and they'll be meandering around to find a seat. Our video company of choice is Wingers Media, and we really appreciate y'all being here. They're located in Dallas, Georgia, and we thank them very, very much. They had the nerve to ask me to powder my head because of the shine, and I didn't take it personal. The video is going to be available on our website. It's also probably going to be on YouTube and in a couple other places, America's Funniest Home Videos, maybe. But we'll just have to wait and see. So everybody comb your hair, because you're going to be on film, and if you got cookie crumbs, go ahead and get those cookie crumbs off, because we want you to look good. If you look to the right, we've got some exit doors right there. So if anything happens tonight and we need to go out those doors, follow me, because I'll be the first one out. But those doors go right out to the parking lot right there. We want you also to stop before you leave. That back table back there is going to have some really good information on it. We hadn't put the information out yet because we wanted everybody to pay attention, real good attention to the presentation that's coming. But what we're going to have for you to take with you is some good information. Included is a book that will teach you how to save energy in your home right here. We're going to please pick up one of those. I know the author, and he'll sign it for you for $5 if you want his signature on it. Also, we've got a brand new brochure that we want you to pick up. As information on all GreyStone programs. They'll be available. A do-it-yourself home energy audit form. If you want to do your Steve, if you want to do an energy audit in your home, you can take this right here. And if you need an interpreter, we'll get you an interpreter. But this is some good information. And also, a great piece of information is this solar sheet right here. It's an informational sheet containing valuable solar information. And this is brought to us by our solar professionals tonight. So be sure to pick that up. There's some real good information on there. We're all about saving energy, all of us, and if for no other reason than just to save money on our utility bills. We can do this by adding insulation to our attics. We can seal air leaks in our house. We can actually just change our furnace filters to save energy. And if solar has that same potential for saving energy and money, then we need to try to learn more about solar. Do you agree? I'm proud to say that GreyStone will be one of 27 electric co-ops in the state that will purchase 100% of the output of a large solar project to be built in Hazelhurst. Anybody know where Hazelhurst is? It's in the United States, isn't it? South Georgia. It will be one of the largest solar projects in the state, covering 135 acres with 878,000 solar modules, producing enough electricity for 3,000 homes. Yes, ma'am. You see those little squares right there? You see those squares right there? That's a module. It can also be called a panel, but it's a module. Good question. This project will be complete and online by the end of next year. Okay, Russ. Thank you. I know some of you are going to have some questions tonight, and I think I know what a lot of them is going to be, so I'm going to ask them for you right here in the beginning, okay? Here are some questions that you're going to see answered during the presentation tonight. What is solar PV, photovoltaic panels or modules, and how does it work? Am I a candidate to install solar panels on my home? Is it possible for me to install my own home solar system? Can solar power be stored for use at night or on cloudy, rainy days? How long will a home solar system last? What maintenance would be required for a home solar system? How much does a typical home solar system cost? I know none of y'all had that question. Are there incentives or rebates available for installing home solar systems? If a solar system is of interest to me, then what would my next step be? And last, besides solar, what alternatives are available to help save energy? So those are the questions that are going to be answered during the presentation. Now, if you have additional questions, please write them down, and we'll have a question and answer session at the end of the presentation. And if time is short and we don't have a lot of time to do that, when we adjourn here, we're going to ask you to bring those questions to us and to our solar professionals, or to myself if it's a GreyStone question, and we will get those answered for you. Is that fair enough? So we're just going to be basically quiet during the presentation, and everybody's going to get to listen. Okay, Russ, next slide, please. It's now my pleasure to introduce 3 solar industry professionals who've given a lot of time and made a real effort to be here tonight. We appreciate those people being here. First, I want to introduce Jerry Kilgore. Jerry, would you stand up? You can sit down now, Jerry. And first, we want to thank you for getting a haircut before you came tonight. Thank you very much. Jerry is the owner of Suncatcher of Atlanta, located in Marietta. He started his business in 1984. It's about the only thing he's ever done. He got out of college and he went into the solar panel business that long ago, believe it or not. He installs home solar systems, has been installing since that date. He's very experienced in installation of solar PV and solar thermal water heating and also solar heating for pools. Jerry, thank you very much for being here. We appreciate it. Thank you very much.
Appreciate you having us.
And Roger Cohn. Roger, would you stand up, please? Roger is the owner of So-and-So Solar. That's an acronym for Southern Environmental Solutions, a business he and his family started in 2004. Roger's been installing home solar systems since that time, and like Jerry, he's very, very knowledgeable about all things solar. And Roger, we appreciate you being here.
Thank you.
Our keynote speaker tonight is Russ Cordy. Russ will present his credentials himself in just a few seconds. I've worked closely with Russ for several weeks preparing for the seminar tonight, and believe me when I tell you that we've worked pretty hard, mostly Russ, on putting this together, and I've gotten to know and respect him a lot. And Russ is going to come up in just a minute, but I would like to introduce his better half, Mary. Mary, would you stand up? This is Russ's wife, and Russ must be good for his wife to come to this meeting and listen to him tonight. And blessed. Believe me, Russ knows a lot about the solar business, and you're going to enjoy his presentation. Russ.
Thank you, Rudy. I appreciate it very much. It's hard to come from behind those door prizes. Wow. The best thing I can offer you is a $5 discount on that autograph that he was, promoting earlier. So, that's about all I got at this point. So, thank you all for having me here. This is the first time I've done some kind of a venue like this large. Typically, it's a lot of the trade and trying to, think or work on certain aspects of solar. And so kind of excited to do that. It's a good chance to hone some skills, and hopefully what we put together tonight is comprehensive and will give you an idea so you feel a little bit better about looking at this as an alternative for you. A little bit about me. I've been in electrical distribution for 37 years now. This is all I've done on my side as well. And the company I work for has been an electrical distributor 104 years. And we are now employee-owned, which we're really, really excited about. And based here in Atlanta, we're also in Michigan, Ohio, and the Carolinas, and we have a location in Germany as well. Currently, I've got this Energy Force logo here. You can see that on the lower part of the screen. That's a lot of what I focus on currently today, is to help our customers, our customer base. A lot of what we do are Fortune 500 companies, big companies that you see the big logos and all the buildings around Atlanta, et cetera. 3 things I focus on: efficiency, very, very big, and that's where you really start in this energy run that this race that we're trying to do, is to focus on that, because that's the low-hanging fruit. You can typically do things to reduce energy by approaching those things from an efficiency standpoint. Secondly is sustainability and renewables, things that we can do to help out, and solar being a really big part of that. And the last one, smart devices, things that can help load shedding when demand and peak is starting to raise, or devices that are getting really popular now are these little plugs and plug strips that you can put in your home. I'll give you an example. Is how many of you have walked through your house with all the lights out at night and it seems like it's glowing now? your VCR, your coffee pot, the microwave. I go walk in my kitchen, I have 5 clocks, glaring at me. And so that's what we call phantom power. And that's power that's being consumed and used, but is that smart? So that we're getting smarter and smarter at some of those devices, and we're putting things in place to help curb that. So again, some of those things that I'm focusing on today. What we're going to try to accomplish today is, as my buddy Rudy had talked about with the questions, I kind of put this together in these 4 areas or 5 areas. Solar in Georgia, does that make sense? Obviously we're here in Georgia, so we want to know about Georgia. The types of solar that's out there, the components of solar, how do I collect it, how do I make it happen? Considerations, very, very key, and we'll talk more about that. And then obviously incentives. And again, we tried to make this a 101, kind of a beginner's part, so those of you that are very familiar with that, so I'm sorry if we kind of started some of the basics, but we thought that we would do this as the first opportunity to kind of start from the ground floor and build up from there. A lot of people wonder, is solar a good for Georgia? And a lot of people think that it's only good for out west. We saw a lot of that. That's where it kind of started. That's where it seemed to blossom. A lot of that was because of, if you look at that zone, you see that there's 6 hours. Well, we have more than 6 hours of daylight, don't we? Well, we're talking about peak performance here, and that's where you're really looking at the radiances of solar. If you look in zone 4, you see where Georgia happens to be. We get a good 4.5 hours of daylight. So there's more than enough sun for us to have a good ROI story to get your investment and your payback. So if you look at that zone 4, if you follow it, it goes all the way up into the Midwestern states. It comes even back around the top of California. Even zone 1, which has that 6 hour, if you'll notice, that's really dense there, where you see Nevada and I guess that's Arizona and California kind of come together. So it's actually really a small area that's got that really concentrated part. And you'll see that a little bit better here. This is more of the rainbow effect, and it kind of shows it as a color in this irradiance chart. You'll see the belt line of the yellow going up, and then you'll see that really dark red. It almost looks like a Doppler radar, doesn't it? The concentrated rain. But again, it's a really small area that tends to have the most. I think a lot of it's some hills and some elevations getting a little higher up, and so that's why they are impacted there more with the sun. But again, if you look at that, you kind of see we're actually in a good place. Even with Florida, we actually are better than Florida in that regard, because Florida has a lot of cloudy days and adverse weathers and conditions and things like that, humidity and what have you. So we actually can do a better job with it here. How do we compare in the world? You'll notice again, we're talking about the colors. You can see the yellow band. If you look at it going across the globe, you'll see that it kind of follows suit. The next largest area is China. And for those, let's see if I can get my mouse, this is China area, and you can see it's pretty bright yellow. But again, even with the United States as a whole, in comparison, we're really well suited for that. Germany, who led the world in solar production, is right there. And what color is that? That's green. So we're actually better poised to actually generate power in this part of the country than they were, and they've led. I heard last year that I think it was a day during July that 37% of the power that was generated with solar. So it's pretty neat, because they have a very aging system and they just can't add capacity to their grid. So it's really helping them out with their crisis there. But again, really well suited. The bottom half, as you can see, where solar is growing. And this is what it's kind of anticipated to do in 2018. One of the things that a lot of the folks that are looking at it, the chemical side, the physical side, the weather conditions, they actually rate this into a sun index. And you can see that out of the states in the top 10, we're actually right up in there, which is really neat to see. So bottom line is solar is very viable here in the state. There's some large programs going on right now with Georgia Power through 2016 to have 800 megawatt installed by the end of 2016. So a lot of investments in going into that. South Face does a lot of environmental watching and tracking and helping out with collecting data. And the reason I kind of put this chart up there for you is you'll notice that you can see a lot of the installations. These are registered. There's a lot of systems that aren't even registered. They're not online and that kind of thing. And so they're not even included in this slide for you. But when I saw this and I looked at it, what really impressed me was how scattered out, how evenly it was spread throughout the state. I think with what we're seeing now and the systems and the incentives of what's going out now, more and more is going to continue to grow around that below Macon. I think you're going to see that really grow in popularity, population of solar installations, I should say, between the next 3 years, 14, 15, and 16. So that is continually to grow. Again, if it's a site you want to take a look at, you can drill down a lot of different things. You'll see there's solar electric, solar hot water, and now we're seeing solar farms, which we didn't have here. The biggest in the state is over in Social Circle. It's 38.6 megawatt, and it's right at 175 acres. Types of solar. Two of the most popular, and we'll just touch on this tonight, is the first one is solar thermal. We won't dive into that too deep today, but you'll notice that collector, or those panels, if you will, look a little bit different than what you see over there against the wall. You'll see some tubes there, and basically what we're doing there is we're running water through those tubes. You can see in the little model to your right, the sun is actually penetrating through that, heating the water up, and then you have some controls and pumps and various things that flow, that gravity, etc., that is moving that water around. So again, here's a good use of that, and very cost effective. Talk to Jerry, talk to Roger. They're on that side of it, and they can give you some ideas of what it would take to do that, but a very effective use of that. Solar PV, so we'll take and dive into that. You can see a little bit different again from the collector we saw. This now looking a little bit more like you see over here. And one of the things, just want to touch briefly, you'll see there's a couple of different types of modules over there. So again, ask any of these guys about which one might be best for your application. Photovoltaic, what is this? That's a long word. You'll hear us a lot in the trade. We'll say solar PV for short, but photovoltaic comes from the Greek word photo, which means light, and volt from the electromotive force, which basically was named after the Italian physicist Volta. He was the inventor of the battery. The thing that really surprised me, and that I was, as I learned a little bit about solar and getting into it 5 years or so ago now, it was that this has been going on since 1849, this technology and these phenomenons, and I didn't really realize that in it's been going on and the ways we've used it, and so now we're getting more and more efficient with it. But what you see here also is this is the foundation of everything. It's that cell, and that technology is really what's revolutionized solar as we see it today. So how does that cell work? Basically, electrons are basically sitting, you'll have the glass that you see it, and then you'll see some crystalline, what have you. Well, we actually charge that. So the top part's got a positive and the bottom part's got a negative. And then as the sun comes across it, you'll see that light energy. Basically, it excites those, and the electrons start moving. Well, that movement is what generates the electricity. And these little lines that you see on the cells, and you can actually see that on each of the product, that's actually what's collecting that. And so as it moves across that, it jumps on the wire, and then it's actually channeled out. And then we actually collect that, and each of these are wired together, and then it ultimately comes off the module. Talk a little bit about how actually cells are made. Cells are made, the core product is a silicone. They gather that up, they bring it in, We heat it in this crucible. It looks very much like what you see this young lady putting some silicone in there and getting it set up. They heat that up to a melt that you see in that picture. And then they have grown some seed crystals that they use from time to time. It's about the size of a pencil, and they dip it in there, and through serious processes, bringing it out, cooling it, setting it back down, and pulling it back out, they develop this large crystal, and the large crystal comes out pretty good size, probably about 8 inches. And from there, we actually start that process. But in your higher end products, this is the key, that the technology that's developed around that crystal and the quality, so that when we actually slice it, we can actually get the power that we're doing today. And I'll talk more about that in just a little bit. But that's what's really made the biggest difference. Before, polys were coming out and we were kind of pulling and pasting and cutting and some of that. And today we're actually growing crystals, which is really, really neat. Once the crystal is cooled and settled down, we actually will take it into a milling machine, and they actually will mill it down to these ignits. We actually get them into a size. Then they start shaping it up, and you can actually see one there. It looks like a loaf of bread. And then you actually slice it into these really thin wafers. And I've actually picked them up, and about every time I've picked one up, I break it. It's actually that thin at that point, and very, very fragile. But going through the process that will follow up, it continues to get stronger and stronger. They are now put into cartridges, and one of the things that I've learned about that is when we tried to do a lot of this with hand and soldering, and we weren't really efficient in making them. And now they develop with technology with vacuum little suction cups that can move it. They're not having the breakage, and the quality and is really, really good. So they load these into cartridges. It goes into a machine. We actually start putting those layers of the phosphors down, the positive, the negatives, etc. And then once those are put in place, we actually start laying down the wires and the conductors to actually pull that together. And that's actually printed on each cell. One of the key things that happens after that is the cells are actually flashed, because what makes a 250 watt module versus a 280 watt modules is the strength and the quality of that crystal. And so each of the products are tested, and that's how they're actually sorted out into groups. They flash test it with 1,000 watts. It's a universal test that's used industry-wide. You'll see that on the back of the cut sheets. You actually have to state that. There's a couple of different ways they do it. They do it at 1,000 and they do it at 800, and they compare the two. But that's an industry-wide standard. So if you're looking at your modules, you want to look at that information to see what that actually flashed. The other thing is out there that I would also tell you is that there's a lot of product out there. When you buy it, there's certain companies that say it's a 250 watt module, for example. Look at what else it says next to it, because it can say plus or minus 5%. If it's a 250 watt module, it could be actually 5% below that, which 5% of 250 is a significant amount, or 5% above. Well, that's a 10% difference. So be careful of what you're buying out there. For example, some of the products you see there was what's called plus sorted. So it's actually, it will be at least, it's guaranteed at like a 250, or if it's a 280, it'll be guaranteed that, but it may be 5% above, but they will guarantee that nameplate rating on it. So look for that when you're looking at your modules. Very, very important, because that's what's generating your power. 10% of your system, if you had a 5,000 watt system and you don't have 10% of what you thought you might, that's 500 watts. So that's a considerable amount of loss if you don't have good modules out there. So very important. Other thing too of note is here in Norcross, we're blessed to have a company that actually makes the cells here. I don't know if many of you knew this, a company called Suniva. It was kind of grown out of Georgia Tech. Georgia Tech has a photovoltaic college, a department over there, and the professor over there, I see some tech guys in the back going on. Yeah, okay. Well, you know, ACS. But anyway, so we took in and developed that technology, and they've come out with a really good product there. And you can actually go by there and see it. Just call, get an appointment, and they will actually take you through so you can see some of this being made. And it's pretty interesting. You'll have to suit up, put your hairnet on, your little booties and a white smock and that kind of thing, but it is an interesting process. You can see it actually, where they're actually shaving it and doing that. Suniva, S-U-N-I-V-A. And they're right here in Norcross, but again, you're welcome to go by there and check them out. It's pretty cool. It's worth the tour. If you know of some schools and kids that, they'd love to host them and get them to come by certain parts, it's a little easier to do it in certain areas than other areas, but they would love to show off their system there, so that's available. After the cells have been flashed and they've been graded, now we know we've got a bunch of 250s, we know we have a bunch of 280s, etc. There in the lower left, you see we're actually stringing them together. Your typical module, you have residential, I would say on that, is what we're kind of focusing on, is typically a 60 cell. So you're going to have 6 columns of 10. And those are strings. So each of those columns, as you see them, we call this portrait style. I'm sorry, I'm using a lot of language you may not quite be used to, but orientation, that's how they're actually wired together. And that's how we pull those things together. And then across the top, and you can actually see that it looks like a little silver banding, and that's the actual how they're wired together there. After they're actually strung together, and it goes through a constant testing process along the way. That's the neat thing about these machines now. They're actually laminated, which means they're put together with a backing sheet and glass, and then they're assembled into a frame. And then the frames are actually tested and checked at multiple points for appearance and aesthetics. But they go back to the flash test, and they're actually tested as an assembly. And they're actually graded again there to make sure that as an assembly, if I had a bunch of 280 watt cells, that I'm actually getting a 280 watt module assembly. So one more time, they're tested as they go out. And if they pass the grade, then they actually get packaged up and sent out. We were using some talking about polys and monos, and talk a little bit about the actual module itself. The modules or panels, we kind of use that sometimes interchangeably, but that's what actually collects the sun rays and converts them to DC power. We talked about the actual cell, how that works individually. 2 types are crystalline and thin film. Thin film is a more flexible product. I'll give you a good example of thin film that many of you probably have saw, didn't realize it. But if you're coming up I-75 and you hang a right on 675, just before you get to 285, you see a big green mountain, and you've seen some solar sitting on it. That's 1 megawatt of thin film. And thin film is flexible, it'll move. It doesn't require a frame. You can put it in a frame, but it doesn't require a frame. And what's happening there is the landfill, as it continues to kind of implode as it's degrading and things like that, is doing the things it's supposed to inside, that actually can ride down. Great application for thin film. Quonset huts where you have irregular shapes. MARTA's got a bunch of it on some of their facilities with those. We're seeing them showing up now on golf carts and pontoon boats. I mean, it goes on and on. But that is a good application for it. The crystalline, higher efficiency, watts per square foot, but a little higher cost. So if you've got a constrained roof, typically you're going to get more output with a crystalline system. Again, thin film, lower efficiency, lower cost. To get the same amount of wattage output of a system, you're going to require more square footage. So if you have a big green mountain, you got lots of space, it's very cost effective there. One of the questions was, how long will a system last? So I'll try to cover that with some warranty information, but typically most across the board I see with various manufacturers, it's a 10-year limited warranty on the product, on workmanship, that kind of thing. 25 linear performance warranty on output. So you might have a small drop initially and just it grades over time, but still I've seen some, Mr. Jerry was talking about being in the business since '84. I'm aware of some panels that were pulled out of service that were installed in 1973 that were still generating solar. So it's really neat to see that. Modules typically account for approximately 70% of system total cost. So back to what I was talking about, that 5%, you want to make sure you get what you're buying, and you want a good quality product with that, because that is a big piece of your costs and outlay. Efficiencies. A lot of people were really spending a lot of focus on efficiencies and modules, and you can really focus hard on that, but the thing that I've kind of learned at with the guys that are really talking about some of the super large projects, it's about power. And so we're continually improving that. This is a very busy eye chart, but the story here is that we're getting better. You see the graph kind of going in the right direction. Someone sent me a video, or a poster, I guess it was actually, they shot. It had a picture of the sun, and then you got this little dot over here with the Earth, and it's talking about, is this big enough to power this? And then you think about the Earth, and then how much of the sun's rays actually go past the Earth out. And so we're not even capturing that. It'd be neat if we could capture that loss side of it. But the efficiency is that different technologies over the years, you can see this going back to 75. The blue area there you see is the crystalline products, the thin film down below it in green. Some of the newer upstarts that are happening as of late, you can see they're even jumping out at the very beginning with efficiencies. The higher end stuff is product that you would see typically like on Space Lab. Really high end stuff, very dense, high grade, and generates a lot of power. So that's kind of what you're seeing there. So the key is it's getting better and better. When I started this 5 years ago, the high-end module was around a $230, and we were over $2 a watt. Today, we've got 280s, and I'm less than half that in price. And it's the same footprint. It's the same size module. We're not getting bigger modules to get that. We're actually staying in that same footprint. So that's exciting to see that cost is going way down, and the power continues to get better and better with that. So again, don't hang your hat on efficiency. It's about the power. It's about wattage and amps and volts, that kind of thing. That's what's generating your power for you. Some additional terminology as we're talking about that. If we come out and you have an installer coming out to your site, he's going to use some words. You may not know what that means. We'll build this up. So we're going to start with a cell. The cell is a component of the module or the panel. We kind of, again, use that interchangeably. How we actually start developing our power is we're going to put those in strings, and we're going to wire those together. There's various ways of doing that, and I'm going to come into that in a little bit later. And then the system that sits on your house, when I pull all that together, ultimately we're going to call that an array. So that's basically some basic terminology on the module side of how we start building that system. So cell, module, string, and then array. It's not uncommon to have a couple of strings. You can, again, like with this array, we might do it a couple of different ways. We could actually have 3 strings, or 2 strings of 6, or just 1 string of 12. I mean, just a couple of ways we could do that. So basics. This would be a system. You're seeing the power lines coming in. You're kind of used to that. You got your utility meter and electric panel. Well, in solar, we kind of work backwards. It's maybe hard to see in this picture, but you've actually got some little yellow arrows pointing in. With solar, we're actually coming off the house with the power that's been generated. What you don't see there is some racking. The racking is what's actually holding the modules together, and that's actually what you're going to attach to the roof, and I'll come back to that part of it. We'll break each of these down for you. That is now generating DC power, and it's actually coming into the inverter, and then the inverter sometimes are separately metered with a generation meter. You're going to have an isolation disconnect, so you can actually, through that, you can isolate. These are some safety things, so you can service points, what have you, and then it'll actually going into the meter. And we'll break each of those down as we get into the coming slides here. So what size solar system do I need? What we see probably majority of the time, the majority of the systems that we typically ship out. And I see this, I cover Florida, Georgia, Tennessee, et cetera, is about a 5 kW, 5,000 watts. That seems to be the most common. If you go back to our irradiation chart, remember we had 4.5 hours of solar. That's good solar. So that's kind of what we kind of try to, if you will, bank or design. This is being conservative because you know there's more than 4.5 hours of daylight. So in utilizing this, we do everything in solar in kilowatts, and so we're going to convert that to kilowatts. And so you take your 4.5 times 1,000, that'll give you 4.5 kilowatts per hour. If you had a typical 5K system, now we would be able to generate it during that day, during that period, what we call solar hours, 22.5. And that's what you would look at and kind of compare, and your solar installer can help you with that, looking at your power bill. One of the things that will help him to help you is to give you 12 months of your power bill, not just 1 month, because you're going to use power differently throughout the year. So it's a really good idea if you can give them that, because then you can kind of take some averaging of what would be best for you. 2 years, you don't need anything more than that, but usually 1 year, I would say, is typically enough. So that's helpful for them. And then again, that way they can make sure that that's meeting the goals that you're trying to do. And again, that's dependent on space, and we'll talk more about that. Each module is 40 by 66. A typical array would require 20 250s. Obviously, if I used a 280, we might be less than that. And sometimes we do that when we're trying to compress or maximize how much we actually get out of a system in our square footage. But did some quick figuring, and so if you take that 20, we can configure this. So you'll notice we could have it in 2 rows of 10, we could have 4 columns or of 5 rows, 5, 4. You'll notice this roof line, if you see that, we've got on the right side, we've got one size array. Down in the middle, underneath that window area there, you'll see another type of array, and then over on your right-hand side, you'll see another size. So they really maximize this roof space with various sizes, and we can accomplish that. They don't have to all be butted up against each other, those kind of things. So again, depending on what roof space we may have, sometimes we're working around roof penetrations, plumbing stacks, air conditioning, vent stacks, things like that. And there's a really good way that we can look at some of that even early on with some preliminary site visits for you. And then each module, your atypical 60 cell weighs about 45 pounds. So one of the things when we're looking at a system going on your roof, the racking, all of that is typically aluminum, so we try to get it as lightweight, but it's very, very strong. How important is the placement of my solar array? Typically, to optimize that, we talked about those radiance charts that we had earlier. We need to get as south-facing as possible, and that optimal angle is 33 degrees, which is your atypical 612 pitch roof. The picture on your left that has a swimming pool, for example, I took this off of Google Earth. The swimming pool is south. So that is the back side of the house. And so you can see with that example, I've got a little bit of usable space there that I actually can put my solar array on. The house on your right, you'll see the sidewalk, that's actually the front of the house. So chances are some subdivisions may or may not let you. That's why you'll see there's a black product over there. Quite often the black product is used for situations where it may go on the front of a house or the customer just wants to hide it. But it's really popular for that. But again, you'll see there's some usable space there, and that orientation is there. So how do you tell if you're south facing? What I'd suggest is go to Google Maps, go to MapQuest if you're just curious about that. It's one of the things that your solar installer can do is he may ask you for your address, certainly how to get to your house, but he may also, while he's on the phone with you, pull this up. And a couple of reasons why. If you'll notice that house on your left, it's kind of got the reddish brown shingles. I got a lot of different roof lines there to deal with. So it sometimes can be a challenge for your installer to give you a decent sized system when I've got a roof chopped up like that. The house in the middle, I've got nice roof space, but it's facing east-west. So we can still do some things with that, but we may have like a system half and half. And again, we might wire it with a different product. The house on your far right, okay, we've got some usable space there. You can see that on the south side, but what do you notice around it? Shading, trees, exactly. So again, sometimes we don't think about that, but if you're looking at it from that bird's eye view, it can give you a good, quick snapshot. Maybe am I a candidate? A lot of people ask me, do I have solar in my house? Well, not this house. When we bought this house in '96, we weren't thinking about solar at the time. And I have trees, my neighbor's trees actually cover my house. So yeah, we're not good candidates for that. We've got landscape solar, but not on the house. All right, well, let's talk a little bit about, you'll hear some terminologies, I'm sure, about grid and backup and also the off-grid. Most residential systems are typically grid tied. The backup can be accomplished a couple of different ways, battery generator and off-grid. Doesn't necessarily have to be remote side. It just usually means that it's not tied to the AC power. Typically, these are DC systems. They're typically 24 volt or 12 volt. Various reasons. We're seeing them now on construction sites with cameras for security. We have water departments, utilities using them for remote sites and getting information back by cell modems now, just all kinds of unique. As you travel down the interstates, you see the solar panels up. DOT's using them for powering a lot of their remote stuff. Good applications for those. But tonight we're just going to talk mostly about the grid tied. If you do have a backup question, these guys are really good with that and would be glad to talk more in depth with that. But we're going to try to keep it the basics tonight. Here's a picture of a house, so we're going to drill down a little bit more in here. But again, as you come in, you've got your solar panels up top, you have your inverter going into the panel. Out of the panel, you're consuming that with you see some lights, maybe I think that's a TV washer dryer. And then so anything that is not consumed with inside the house, then you could possibly push it back out to the meter. And GreyStone has a net metering program here, which is very advantageous and a very cost-effective way to go about getting into that. We're going to take each of these components now and break them down. The next item besides the module is the inverter. The inverter, its job is to convert the DC power over to AC. There's various types, microinverters, hybrid inverters using an optimizer, and string inverters, and I'm going to break those down for you, so hang in there. And typically, as I was saying earlier in a couple of slides, that we'll look at the application. We're trying to get you the most power out of a site, so we may use one of these various applications to help you achieve what you're trying to do. Inverters do require engineering because the modules are basically dumb devices. Sun comes up, they want to start generating power, but you got to control that power, and that's what the inverter does. So it's one of the things we'll do is we'll look what is the coldest day of the year, because solar loves cold, much like LED loves cold. When it's cold, it really can pump out a lot of voltage, and so you have to be careful of that. So we size the inverters and the module matchups with the stringing based on that. On hot days, they tend to not produce as much, so it's typically not as big a deal, but we also want to make sure you're getting enough output. So we'll look at those variables when we're actually sizing some of your inverters. Efficiencies, I've got down there in the 94 to 95 because I've seen a lot of different technologies. The products that our company has tried to sell, we're trying to stay in the 98 plus efficiency. For example, our little microinverter is like 99.4% efficient. Most of the product that we're selling today doesn't have transformers in it. Most everything is solid state electronic, and we're not utilizing the transformers that weren't really efficient inside that design. So A way that we capture that data so that you can see how your system is performing is typically web enabled. Sometimes, well, most, I guess everything now pretty much, except for the microinverter, you can take Ethernet. I think most of us probably have that in our home now, and you can plug right into it. And then it actually gives you a web address. You type it into your computer, and now you're looking to a portal or a window. That's very, very easy to do, and you actually can see your system and how it's performing. And the microinverters actually use a little wires device, and it actually runs through the power line and does it a little bit different, but you can actually plug it in and then see it as well. We can still get you on a computer, on a laptop with that device as well. So a couple of ways to see that data. It's a lot of fun to see what your system is doing over time. Types of inverters. Will my system provide power to my house when utility service is out? So one of the things that we get a lot of questions about is, where do you store it? And then what happens when the power goes? I'm still going to be able to run my lights and things like that. And the where you store it is one of the things there is that we typically don't necessarily need to store solar. You need to store solar if you need power when the grid is down. But what we're typically doing is we're trying to offset things. We're trying to reduce. We're trying to be more efficient. On this question, there's a big safety concern here, and the answer is no. It's a safety thing. UL 1741. With these systems being grid tied, they're designed to disconnect and not backfeed the utility system when the power's down. This way, the solar system's isolated and will not cause injury should someone be working down the street on your power lines. When power goes down, we're wanting the guys to get out there and work on those lines quickly, right? Well, we want to make sure they're safe. And UL 1741, it's called anti-islanding, and it's a feature that actually will shut that inverter off. Now, that module's still producing voltage during the day, and that inverter on the DC side is still going to be live. But until it senses voltage, it's going to stay in a sleep mode, if you will. It also uses that voltage to maintain the power that it puts out. So it senses if I have 240 volt, which is typically what we have in the house, it's going to produce 241. That's how it actually pushes it into your house. So it requires that voltage, number one, to operate, but most importantly as a safety feature. Very, very key, 1741, that it'll actually shut down as a safety thing. There has been a new revolution in this, in a change. UL 1669. There are some products out there. I've actually got a picture of one of those. It's a product made by SMA that has standby secure power. And what they were able to do is through some firmware and software in their inverter, when you have daylight hours and the grid goes down, they have a safety circuit in there that allow you to power 1500 watts. It's a receptacle that goes at the bottom of it. It goes through a timing safety circuit check. It actually will have it has an output contactor, and it actually will open up that circuit. So it actually separates your grid, your line voltage from your system so that it will actually power that outlet. Now, 1500 watts probably won't power most anybody's toaster these days. So it's really for things like cell phones or radios, emergency type devices. It's not a lot of power, it's a little bit of power, but the key there is that they have developed the technology again to protect that, and it's isolated that. Should power come back on, that solar is not going to go back out to the grid until you go back and switch it back into the grid mode. And then it goes back through its checks to make sure that it's got good voltage and everything. Then it actually will disconnect the outlet, and then it starts powering it back up. It takes about 2 minutes to go through that cycle. So it is something new that's come out recently, and it is available. But very, very key that we protect the power there. It's another thing, too, along that lines is if your house is on fire, one of the first things a firefighter is going to do is he's going to come over there and pull the meter. And that's why it's important to have the tags. You'll see a lot of those over there to make sure that they understand there's a solar system on the house. They'll pull the meter, and when they pull the meter, that shuts the inverter off, and it isolates it there, so we're not putting it in the house. Very key. Inverter, microinverter. A microinverter basically sits behind the module, It nestles up there really nice to it. What's nice about an inverter, a microinverter, is it'll give you module level production, and you can actually monitor it, and I'll talk more about that. But there's two sizes today because of the power density with modules, as I was sharing with you, is growing. We used to have an M190. They don't even make it anymore. It was for smaller, those 230s that we don't even make today. The 215 will go up to 270 watts, and now the 250 going up to 300 watts. It uses a trunk line, so when I'm coming off of this, I've now, right behind the module, I've converted from DC to AC. So that trunk line is AC. Again, we do have online monitoring there. You're getting that performance per module. If you look at that house that you see pictured there, you'll notice that, well, I don't really have a south facing. I've got kind of a split up system. So you notice it's also got a lot of shading there. So microinverter might be a way to do that. Based on this picture, I'm not sure that was the best application, but I don't know what time of day and the other circumstances around it. But again, these are some areas where a microinverter might be what you could get the most out of it. Here's really how the module works itself with the microinverter. On your left-hand side, we're going to talk about a string. This is a comparison. In this particular model, these modules, all the way across, all 6 modules you see, they're actually, just think they're 215 watts, okay? If you got some shading, you'll notice on the left-hand side, the third one coming in, I'm only getting 90 watts out. Because these things are wired in a string, they're wired in series, I'm actually pulling my whole system down. That's the physics of the way these modules work, because you're wiring them in series, like wiring a battery in series. So my system there, should I have shading on that one particular module, I'm only getting 270 watts out. The system you see on your right, that is the microinverter. So you'll see those 2 modules that are getting its full capacity at 215 watts. The one on the right only producing 90 watts, much like the system you see on your left there, but my total output for that is 520. One of the benefits of a microsystem. Shading, again, if you look at Google Maps, if you have any of that, that may be a good application for that. The multiple roof pitches, multiple arrays, and it's typically a little bit more in cost, but it gives you so much more flexibility in just an inherent design that it has. String inverter, that's again where we're wiring that in series, pulling those things together. Your modules need to be the same. Typically, it's best to have them same brand. One of the things you have to be careful is you're thinking about down the road, down the future, that you want to make sure that you pick modules, or maybe you buy them and you set them aside, something like that, because you don't want to mismatch with the string. It's very hard to do. You can come up with some dual MPPs. If we had 2 arrays having them split, they could be different sizes and systems, but whatever's on a string's got to be the same. Typically that inverter is, most of them are NEMA 4. There are some NEMA 3R, so you can mount them out on the outside of a house. A lot of folks like to put them on the inside of the house, but those do have a 10-year warranty, and typically this system is the lower in cost installation-wise. And then you have the hybrid system. The hybrid system is kind of taking the best of both technologies. We're utilizing what we call an optimizer, and that's the little black box you see there with the little aluminum bracket, and again we have a sample of that, and you're also using an inverter. The secret sauce here behind that is that this optimizer, it's going to optimize, as it's saying, the voltage in amperage. It's an inverse relationship. Typically what happens is you get strings out there, again, depending on whether it's dirty, slightly cloudy, as the sun's coming up, the different angles that it's hitting it. What the optimizer does is it makes sure that all of the optimizers are putting out the same voltage. And so they're constantly like talking to each other and making sure that everybody, and so they actually can borrow power from one another and actually raise the system up. Typically, these are putting out 25% more power than a typical either micro or string system. Some minor limits in that you have to have a minimum of 8 modules, and there's some limitations on the maximum size of those strings. On the inverter itself is a 12-year warranty, and then again the optimizer, which again that sets up underneath the module, that's a 25-year. And it's positioned typically between the microinverter and the string inverter. Can power be stored for use at night on cloudy or rainy days? It can. Typically, you have to be very careful of that. You remember UL 1741? So if I've got a generator out there, if I've got power, a battery, and I'm now rectifying it or inverting it, depending on what you're doing, you got to be careful of that. And one of the key parts about that is not only just the battery technology and how much you want stored, but it's the safety aspect. So a lot of that has to be designed into that. It can certainly be done, but you have to be very, very careful of that. The thing there that I would just kind of think about what your critical loads are. What are your goals? What are you trying to do as you look at that and size it? So typically your installers will kind of get an idea of what it is. Very, very hard. You can generate a lot of power with solar, but then when starting the battery backup, the battery technology is getting phenomenal today. Where we were at 5 years ago, where we were at 10 years ago is just no comparison. I look at our cell phones today and how long the batteries are lasting. They're getting better and better with them doing so much more, and the technologies, it's just amazing what's happened out there. Okay, so we've got the modules, we've got the inverters. Now we're going to attach it to the house. So we call that racking in the industry, and that's what's going to support the panels. It's going to hold them in place. We usually configure 2 things. We're talking about snow loads. We don't have to worry about that too often here in Georgia. We did a little bit last year, but up in Michigan, they typically are sizing systems, so my counterparts are for 50-pound snow loads. So I'm glad we don't have to do that. However, I'm working on systems in Pensacola, for example, and I'm dealing with the 160-mile-an-hour wind loads. That's the uplift. So you have downward pressure and you have uplift. And so we're looking at both of those. Residentially, typically it's mounting on roof trusses, so the guys will locate those, and we have some standoffs. You can see a picture there. We've got a couple of those demos here with the flashing, so you can see what that looks like. Ballasted system, if you have a older home, older structure, it may be flat, pea gravel, those kind of rooftops, good application for a ballasted system because it doesn't penetrate. We basically can load that up with some block, and it spreads that out. You see that a lot in a lot of places. They're putting up these little dish antennas, and you've probably noticed them on subway stations or something like that, subway sandwich shops. I see them all the time, but they're using ballasted. They've been using that for a long time, that system. If you don't have roof space, but you got plenty of ground, if you got plenty of dirt, a ground mount might be a viable system for you. And can be a cost-effective way of getting a system, and I'll show you a little bit about that. Angle is important. Angle does work better in the summer months, steeper angles for the winter. Again, we know that the sun changes angle, different parts of the year. In Georgia, we're pretty fortunate that we don't have to, even on these large solar farms, I'm not aware of anybody yet that's put a tracking system in it. You remember we were looking at the radiance charts where they were doing that out west, and we had those really hot zones. To get those 6 hours, one of the things they're doing is they're putting tracking on them, which is another mechanical part that's moving some things. We don't have to do that in Georgia. It's really neat. Pitched roof, basically that's your atypical composition shingle that just most of us have in our homes. We can basically hit any kind of speed constraint, especially in Georgia. We're typically around 90 to 110, somewhere around there. So, we're good there. But again, we've got pre-engineered configured systems now that we can actually do these online configurators. It's really gotten down to figuring out these things really quick and easy. 10-year warranty, and typically when we do these code configurations that we do, or these online configurations, it's code compliant, and most engineers will, and your inspectors will sign off on it. That's that mechanical loading, so that'll print out all of that data for you. Ballasted racking, a good picture of it. Basically, if you have a minimal pitch, we're even seeing if you have a large distribution center, metal roof, low, they're pretty flat. You can actually put a ballasted system up there. They have a rubber feet on the bottom of them so they don't creep, they don't move, they don't walk. Very good way, again, that you don't penetrate the roof. So installs sometimes half the time. You can do pre-assembly on the floor. They're real lightweight. You carry them up there, you set the blocks, and you're done. It's really, really fast. And I've done ballasted systems in Pensacola up to 140 mile an hour above I-10. So again, they'll handle some wind loads. They sometimes some skirting to divert that a little bit. It also creates downward pressure, which helps. Sometimes you may have to, if it's commercial, typically you run into that more. You have to get engineer certifications with that, but your installers can help you with that. Ground mount, basically what it is, what it says, it's going to mount in the ground. Typically it's a pole or a post. You can have one pole and then you have an array on that, or you can have multiple poles. Again, sometimes it's tilt, angle, size of the systems. This particular system here is actually using a 72 cell module, more of a commercial application, but they're usually those posts, they're like I-beams, they're driven into the ground with the ram. They sometimes are done with concrete or a helical screw, and that's gaining a lot of popularity because all the rock we have in Georgia, we can use a helical at a shallower depth and give you that same or better pull-out strength. What incentives are available for solar? Very, very key. DesireUSA.org is a great website to go. Everybody uses this. So everybody is using this for not only solar, but they're using it for everything efficiency as well. Government entities, federal, city, state, county, anybody is typically utilizing this. So you go to that website, just click on your state, and then here I not only clicked on Georgia, but then I found GreyStone and what GreyStone had available, and I clicked on it, and then you can kind of see, and then you can just scroll down to the bottom of it. A lot of times, as GreyStone has done here, they've done a really good job. They've even got their forms listed right there, so you can go right there, fill out your information, and pull that off. But it's a really good website to go to for current. It's maintained very well, and again, the federal, state, county, whatever local entity is. Great website. To be such a massive program, even on some efficiencies, there was a lot of lighting that was available. EV car charging. If you're looking at buying an EV car, there's still programs out there for the car, not for the charging station anymore. That rolled out, but for the cars, still some pretty good programs on the Leafs and those kind of things. How much does a system typically cost? Just throwing some numbers out there, it's a relative, just to give you some sort of an idea. Again, very application specific. I can't say that enough. So this is just some average numbers nationally, and this is continually to go down. Remember, I was talking about module technology and cost. Modules are going up, so I have to put less on the roof, but also the price of the module is going down. Racking cost is coming down, inverter cost is coming down. It's all good. But to give you an idea, if I had a 5,000 watt system and it was $4 a watt, that would be $20,000. Same thing, conversely, $5 would be $25,000. And again, a lot of criteria. If you think about a roof, if I've got a 312, I got a 612, 912, and I start getting to a 1212 roof, I got nice angle, I got nice pitch for the sun. But then my installer has got to do so much more in gearing up in safety and maybe scaffolding and a lot of things they got to do just to set up to install this safely. You want him to not necessarily spend a lot of time on your roof, but you want to make sure he's not doing a rush job to get off your roof. He's got to get up there and make sure that he does it right. So sometimes that adds a little extra time on the projects. what maintenance would be required for a home solar system? Talk a little bit about your cell question there, but one of the things I get asked a lot here, what about the pollen? Because we tend to see a lot of pollen here in the springtime. Modules are pretty much maintenance free. I mean, you could get up there with Windex and you could clean them and do some of that kind of stuff, but you really don't. Again, they're designed to sit out there in the harshest of environments. The rain pretty much takes care of it. You know, they come in, they're typically, especially if they're angled, another benefit of that 33 degree. If you're flat, you start getting down toward the Caribbean, a little bit more, you know, every now and then hose them off with systems, and they design a lot of that into it. But here, as long as you've got that pitch, the rain pretty much takes care of it. Had the question about the cell performance. One of the things is, again, it depends on your system. If you're watching it and seeing what's going on and you happen to see something that going down, you might, and again, if you've had that system installed, you might holler at your solar installer. If you have a micro system or the hybrid, you can actually look at the performance of the modules. And like with the Solar Edge product, it'll actually start flagging you. You can set parameters in there so that if I happen to have 20 modules sitting on my house and I've got one underperforming a percentage, you can actually set that. If it's, say, falling below 10% of my other modules, it'll actually send you an alarm and it'll give you a flag on your portal. And you can even tie this into your smart device. And so you can actually see which one it is. It'll actually blacken it out so you can troubleshoot. How do I replace it? You're basically replacing the module. Again, it's with those underperforming, they are a 25-year warranty. For example, this manufacturer that we brought you here today, they've never had a recall. And in all the 5 years I've done it, I've had 2 modules that I've had to warranty that didn't perform. But it is simply by pulling it out and getting to it. So as you're sizing your array, again, you don't want to compress everything where you can't get to it. Like in this picture here, I have, just for the sake of saying, it looks like 2 strings there. I can get access to any direction. If I took this room and I just butted modules together and I had one in the middle, I'm going to have a tough time servicing that. So some of the things we try to do is make sure we have ways to service that. So. Before the meeting, there was a gentleman that asked me, what about hail? Because we get that from here from time to time. So I thought I might show you something that might answer that question for you. But wait. So what do you think? Now, I wouldn't have done that 10 years ago with the modules they were making back then, but today, not a problem. They're pretty durable. Take and go bang on them. I think you'll be impressed.
GreyStone Power offers solar rebates for installation of PV, $450 per kW up to a maximum of 10 kW. So if you put an average system on your home that was 5 kW, you're looking at a rebate of 5 times 450. And I didn't go to tech, so I can't figure that out. But it's about that much money. We also have a low-interest home efficiency loan program, 2.9% for up to $5,500 for 3 years. Also, we have a $500 rebate for a solar thermal water heating installation, and we've probably, in our territory, we've probably got about 20 of those right now. Jerry, you probably put in 12 or 14 of them, haven't you? On the thermal, probably. So those are the things that GreyStone are doing now, and you'll be able to pick this information up at the back when you leave. So be sure and pick that information up. So now we're going to have a little question and answer session. And I'm going to ask you to do me a favor. If you've got a question that will be a generic question that everybody would benefit from, please, now's the time to ask it. Okay. Yes, sir.
What does GreyStone pay for energy that we put back into the system?
What do we pay for it? What do we pay for energy that you put back in the system? Now, how much have you put back so far? There are people it put back. I'm going to tell you what we're doing currently. We will pay our avoided costs. In other words, what does it cost us on the average to generate power on the average? And that's what we're required to pay when you put it back on our grid. Now, what happens with our metering system is that power comes in from the solar system and you're using it in your home. If at any time you're generating more power than you're actually using, then that is what goes back to the grid. Currently, we're actually giving you full retail credit for it. We're giving you a credit for the next month. By all the rules, we don't have to do that, but currently that is what we are doing. Does that answer that question for you? Any other? Yes, sir.
Off-roof array, how far away from a house can the array be?
Jerry, would you mind answering that question for him?
You go as far as you want to, you just have to upsize the line underground going to the house. So if you go and see that 10K system in, you might as well put another 6 lines in the ground. Just a line drop is what we call it.
Is that okay? Okay, other questions? Yes, sir.
Would y'all know anything about what homeowner insurance might cover, or how they're dealing with this?
Yeah, it's attached to your house, it's covered under your homeowner's insurance. You can call up the insurance if you want to do it. If you don't, it's still attached. I don't know how much you call every time you put something on your house.
Right.
Yeah, it's covered under your homeowner's.
One advantage too is when you put solar on your house, typically it increases the appraisal value of your home as well.
Yes, ma'am. How does it affect your roof warranty?
Yeah, it affects your warranty. Well, if you do it right on the solar, we try to do it that way by using the flashing kits and all, upraising on the roof. Shouldn't affect it at all.
Typically, that actually makes the roof last longer. If you think about that, it's taking the full brunt of the sun. Okay, and that's why we use the standoffs that we do, and it creates an air path between your roof system and your house. So you're going to get that convection cooling anyway, so that actually cools the solar panel. It also keeps the roof underneath it. So typically, even your attic space, when you put a system up, you'll notice your attic space will actually be cooler. that should actually extend the life on both sides of your roof, not just your south facing, but if you cool that attic space, the north side's going to get the benefit of that as well.
Yes, ma'am.
What's the average cost of the solar water heater?
That's a good question.
Jerry,
Most of our systems are 80-gallon and 120-gallon systems. They can range from anywhere from 5,500 to 10,000.
Yes, sir, Mr. Steve.
I love GreyStone Power,
We love you too, Steve.
but would there be some provisions for going totally off the grid if you wanted to?
You can do that, but you know, you're gonna need them sometime because the battery's not gonna hold up past, you know, ever how many days, but you can do it. You can try it if you wanted to. There are some systems out there that are off grid that live up in the mountains.
Do they operate on AC or DC?
They work on AC systems, they're battery, they have inverters, we call them hybrid inverters, or you can get a off-grid inverter.
Steve, you're going to have to make a lot of money on your next book if you're going to get off the grid, though, I'll tell you that. Other questions? Yes, ma'am.
Do you have to convert any of your appliances or electrical, nothing to, you have to convert anything to where to work with solar?
No, you do not. This is the best electricity you can get. It's real smooth electricity. It doesn't move back and forth. It's smooth.
Also, if you think you're leaking electricity, if you'll take a bucket and you'll put it under your receptacle, any electricity that leaks out, you bring it in, we'll give you a credit for it. We're going to take one more question, and while we're doing that, we're going to be passing out the questionnaire we'd like for you. Actually, we don't have a rebate for that bucket, but if it's a nice bucket, we might buy the bucket from you. Let's take one more question. Yes, sir.
What's my house in particular is almost due east-west. There's a little in south. The difference between going over and doing it east and the west array versus going out in the backyard behind the fence and facing that to the south and running that in, say through my basement, where's the break-even point if you have the worst possible?
Well, you have an east-west exposure. We got all kind of mounts. We call it, you can lay it like we talked about landscaping. So if your roof is that way, we tilt the collectors up that way. Okay. Or we can go what we call portrait style and do it that way across it.
Right.
So they will tilt. We have mounting systems.
Better than going out in your yard,
yeah.
Ground array and running.
Exactly.
How many of you have had an energy audit at your home? Raise your hand, a free energy audit at your home. Okay, all 2 of you, 4 of you, okay. We're going to offer a solar energy audit, and what we don't mind doing, this is free to you at no cost. We'll come out and we'll do an energy audit of your home, and we'll also help you with some basic solar information. We want you to come up and ask any question you might have for our solar professionals, and if you want to go and look at the displays, you're welcome to do that also. Okay, we're going to adjourn now. I want to thank each and every one of you for coming out tonight. I want to thank every member of the GreyStone team for working hard tonight. Thank you very much. We've got our solar professionals. I want to thank Russ Cordy for doing a great job on the presentation tonight. Thank you very much for being here. And you don't have to go. Come around and ask questions if you want to, but when you leave, please pick up the literature out there. It'll really help you. And thank you very much, and we're adjourned.
Monocrystal, what I have on my house, I've had it on there. I've been solar since 1988. system. And basically what we do is we'll slide this into the shingles wrap all the way around this, there's shingles all the way up here. So we seal that down, we use what we call NP1 to seal under the bottom. After we seal the bottom, we'll slide this up, we use a stainless steel lag that'll go down into the roof. It hooks only in the trusses. Once we got that, we'll put our L bracket up. We'll raise that system. This is our solar panels here. We've raised it up 4 inches off the roof. The reason is 2 reasons: keep the leaves and debris to run down. Number 2 reason, to keep the panels cool. The cooler the panel, the more efficient. The hotter the panel, the less efficient. So we keep it off the roof, and this is going to be there for life. These are grounding methods that we've got. As you see our grounding rods, we got it grounded on the rails. We got it grounded here at the very end where we run a ground decking wire down, depending what we're running. We're running number 10 gauge, we're going to drop it down to number 8.
I can help you.
You don't need that. That's usually for the front of the house. That costs a little bit of money. But this is it. It's going to be the 275 like this. Monocrystals. Monocrystal. And
Appraisals go, they allow you the full cost.
that's 279, 280.